Welcome back to our channel. Today we are diving into one of the most crucial topics in system design, load balancing algorithms. Ever wondered how big platforms like Netflix, Google, and Amazon handle millions of users of requests with, without crashing? The answer lies in load balancing, specifically the algorithms that determine how traffic is distributed efficiently. In this video, we will cover what load balancing is and why it's crucial, the most popular load balancing algorithms, how each algorithm works with real world use cases, when to use each algorithm. So, first, what is a load balancer? Load balancing is the process of distributed incoming network traffic across multiple servers to ensure no single service is overwhelmed. It improves performance, reliability, and fault tolerance. Now let's break down the most widely used algorithms in load balancing, starting from the simplest to the most advanced. So we start with round robin. The load balancers forwards each incoming requests to the next server in a cycle order. So when John sends the request, it go to server 1, Sarah sends a request, cycle order, so it goes server 2, John sends another request, it go to server 3, Sarah sends another one, it goes to server 1, and so on and so forth. So it's a cyclic order. Once it reaches the last server, it starts again from the first. Works well when all servers have equal processing power and workloads. It's a great in small scale web applications and evenly distributed workloads. It has some limitation. It doesn't consider server loads, so if one server is slower, it may cause delays. Number two, we have weighted round robin. It's exactly like round robin, but we assign weight to it. So assigns a weight to each server based on its capacity. Server with higher weight receive more requests. So as you can see here, it has better weight than first one. So this one has 0.1 weight and this one have 0.3. So it will take as 3 as much as the server is taking. Um, so as I said before, server with higher weights receives more requests. When the use cases of this algorithm, it's when some servers are more powerful than others. It's a great in cloud environments when servers have different capabilities. It has some limitations because it requires manual weight configuration, which may not be that dynamic. Next, we have least connection load balancing. It sends requests to the server with the fewest active connections. Helps prevent overloading as overloading a server that's already processing many requests. It's best for applications with long-lived connections like database and real-time apps. Example for that like WebSockets, video streaming, and chat application. It has some limitations. It can become inefficient if some requests take much longer to process than others. Next, we have the least response time. It routes traffic to the server with the lowest response time. It considers both active connections and server performance. It's best for high performance application where response time is crucial. Example for that like e-commerce websites, banking application, and API gateways. It has some limitations because it requires continuous monitoring of response times, which can add some complexity. Next, we have IP hash. It uses the client IP address to determine which server handles the request, ensures that the same user always reaches the same server. It's a great for session persistence, sticky sessions, and user-specific caching. Example for that like online gaming, social media platforms, and personalized user experience. It has some limitations because it can lead to uneven distribution if some users generate significantly more traffic than others. There is other things like random load balancing, but it's really used. Basically, it's like a randomly assigns request to server without following any particular order. It's useful when all servers have similar capacity and no need for advanced traffic control. It's great in small microservice application and test environments. It's only great in test environments. It doesn't has real world examples, I guess. And yeah, that's it. I guess we did cover most of the things. In the future, maybe we'll take each one by its own to talk about when to use it and why we should use it or not. So yeah, to wrap it up, now I guess you have a solid understanding of how load balancing algorithms work and when to use them. So what's your favorite load balancing? Let me know in the comment section below.